Hello everyone, welcome to the short webinar series on post-tension PSC bridge design as per Eurocode using Midas Civil Software Solution. My name is Nivedita Kumar. I'm a technical support engineer at Midas. Today's webinar series is going to last for 30 minutes and we have the same 30-minute session for tomorrow and day after tomorrow to complete the entire analysis as well as design and report generation of a PSC composite bridge. So without any further delay, let us begin now with a short presentation and then we will move to Midas Civil for a demonstration. In today's session, we are going to look at the modeling approaches of post-tension bridge. In this, we are going to take a look at the different modeling approaches. One of the approach is with the help of nodes and elements and the other is with the help of wizards. Tomorrow, we have another session at the same time. It will focus on the loading and boundary conditions. It will include the pre-stressing, the static load definitions, moving load definitions, wind loads, dynamic response spectrum analysis, and also we will talk a little about soil structure interaction. Day after tomorrow, that is on the last day, we will see the analysis result extraction and how to generate high quality optimized design reports. So this is about the entire content of the webinar series. Let us go ahead now and start with today's session. I'll firstly introduce you to Midas as a company. Then I'll talk about Midas Civil Software Solution. And then we will move ahead to the main topic of discussion, that is the modeling approaches for PSC Bridge. I'll share the overview of the bridge that we are taking as an example. Then different elements of library of elements to model the PSC bridge. Then we will see how to use nodes and elements to do manual modeling. And we can further look at the end how to make it quick, make the modeling quick using the PSC wizard. After that, I'll summarize today's session and then we will take up question answers. Meanwhile, if you have any questions, please write in the questions box. Let us start with the introduction to Midas. Midas was established in the year 1989 by POSCO Group, and the software solutions by Midas have been distributed in more than 120 countries. We have the headquarters in Seoul, that is South Korea, and all over the world there are 9 branches. Let us look at the family programs of Midas. Under the bridges, we have Midas Civil Software, which can perform the analysis and design of all types of bridges. If you would like to go with some advanced nonlinear and detailed analysis, you can go with Midas FEA software. Under the structures, we have Midas Gen that can perform analysis and design of building structures and general structures. You can generate drawings using Midas drawing software. And there are component design and detailing tools like Midas Set and Design Plus in the structural solutions by Midas. Coming to the geotechnical platform, we have 3D geotechnical software solution called GTS NX and a 2D solution called SoilWorks. These both are based on finite element analysis and analytical solution. Coming to the mechanical, we have Midas NFX and FX Plus. Let us go ahead now and understand about Midas Civil Software Solution. But before that, I would like to take you through a partial list of our worldwide users. You might be knowing some or maybe all of these multinational companies. They're using either our bridges solutions or they're using our structural solutions or geotechnical or more than that. These are some of the companies that are using, local companies that are using Midas software solutions in Africa and South Africa. These are partial lists. Of course, there is a very long list with us who have joined us for Midas software solution. Now I'd like to go ahead to the introduction to Midas Civil. Midas Civil is a one-stop solution for bridge structures where you can perform the analysis as well as design and generate reports of any type of bridge. The applications include simple type of bridges such as box culverts, slab bridges, frame bridges, to medium span bridges such as a PSC girder bridge, box girder bridges, even there is steel composite bridge. Then coming to more long spans, we have high-end bridges like cable stayed bridges, suspension, and extradose bridges. Let us go ahead now to the main part of our today's session, that is the modeling approaches of post-tension bridge. I would like to take you through the user interface of Midas Civil. Midas Civil contains a ribbon menu at the top, and the ribbon menu is divided into number of tabs, and the tabs are arranged as per the work procedure from left to right, where we start with the modeling, apply the boundary conditions, loads, perform the analysis, check the results, and go ahead with the design. We can also generate reports after that using the Tools tab. We have tree menu again that contains different tabs and that can give us information only that is related to our model. It makes it easier for us to do proof checking. While we are doing the modeling, we can see any warnings or errors in the message window. That helps us to avoid the modifications required after the analysis is performed. So beforehand itself, you can know if you have done anything wrong or understand why if any of the command is not working. So this is about the user interface of Midas Civil. It's easy to use and definitely would be handy for any type of bridge. We also can use the tree menu for modifying the cross-section properties. And it's very easy feature. Simply select the member and drag and drop to modify the cross-section. There are several other options available in the tree menu to help you quickly complete your model. Just like we have one tree menu, the first tree menu, we have a second tree menu to help improve the selection processes or to activate or deactivate certain selected member. Material properties and section properties can be defined within Midas Civil. You can also import the material and section properties from an already generated model file or a text file. Coming to the material properties, we have steel, concrete, steel reinforced concrete, that is SRC, and user-defined options to generate the elastic data. Not just that, but Midas Civil contains a huge database for different types of codes, especially the Eurocode and the British Standard, which you might be using. Section properties. It becomes very easy if you have to just input the values instead of using the CAD-based approach where you first create a cross-section in AutoCAD, then import it in a third-party program, and then import it back into the main structural solutions. Of course, when it comes to irregular cross-section, this approach is available in Midas Civil, but when it comes to the most commonly used cross-sections in a bridge, Midas Civil is much faster. So we have the PSC tab for different cross sections for a PSC bridge, like the PSC girder bridge, which we are going to take a look at. Apart from that, even box girders, PSC box girders can be easily modeled, one cell or multi-cell. We also have a library of cross sections as per codes. And we can also use tapered cross sections in Midas Civil. When it comes to steel composite girders, we can create them in Midas Civil itself. Again, there are several tabs available to generate, several options available to generate the required or the desired most commonly used cross sections in a composite bridge. You can also have a general type of composite cross section where the irregularity comes into picture. This is about our section property calculator, where if your cross sections are not available in Midas Civil property definitions, then you can import from an AutoCAD file into SPC and then put it into Midas Civil. So all types of cross sections can be imported for the analysis and design in Midas Civil. Coming to the time-dependent material properties, Midas Civil is capable of handling the long-term pre-stress losses as well as the long-term change in geometric stiffness because of the time, like the creep, shrinkage, and compressive strength. So here we have an auto calculation for the coefficient for creep and shrinkage. We have European standard for that purpose. And this is where we can check the profile of our creep coefficients and shrinkage strain. Similarly, compressive strength function can be generated very easily by simply inputting the data as per the European standard. So this is how we can incorporate the effect of creep, shrinkage, and compressive strength changing with time. Now let us move on to the next part of our today's topic, and that is the modeling approaches of post-tension bridge, overview of PSC bridge. We'll take up an example model of a two-span PSC bridge having 23.02 or rather 23 meter as the span distance. 0.2 is provided or shown over here to talk about the 40 gap in between the two spans. So there will be bearings under each span. We are not considering it to be a continuous type of girder, but simply supported girder. So this is what we are going to do, and the deck width is 15 meters. We will simulate the pier cap as well as the pier. So today we will see how to model a PSC bridge with the superstructure as well as the substructure. In case of the substructure, we are going to model the bearings with the help of elastic link. The bearing height is going to be 100 along with the pedestal. The pier cap will have a length of 13.5 meter, and there will be a single column of a height 10 meter height. So let us go ahead now and understand about the different elements that can be used and when to use for simulating a model in finite elements. Midas Civil has a huge element library. It includes the truss elements, tension only, compression only type of nonlinear elements, general beam or tapered beam like a simple 1D member element having 6 degrees of freedom at each end. Then plate element or shell element, plate or shell is the same. Plane stress, plane strain, asymmetric, asymmetric and solid type of elements. So these are the different type of elements, finite elements that Midas Civil includes. Now let us understand the different modeling methods or how we can simulate and when to simulate which type of using which type of elements. So you can actually create the entire bridge using all frames. The advantage of using all the elements with the help of 1D, all the members with the help of 1D elements is the design. You can generate the PSC girder design as per Eurocode if you have modeled your PSC bridge using frame elements like the general beam or tapered beam type of element. The next approach is the deck as plate. That means your deck element will be, deck member will be modeled using plate elements, and the girder as frame. So the girders will be modeled as frame elements. So in this case, you can generate the information for local buckling in plate, that is the deck. You can also model the entire PSC bridge using plate elements. All will be plate elements, and this would help you for local buckling in all parts of each member. So the more fine your mesh, the more local buckling effect you can check in your members. You can also use all plates for stress analysis, but it would be always better if you want to go for detailed stress check at joints using solid elements. All of these approaches are possible in Midas Civil. So what we are going to do today is we are going to make use of all frame so that we will be able to see the design of our PSC girder as per Eurocode. Let us start with the modeling with the help of manual bridge approach, manual modeling approach using node and elements. The steps would include creating nodes, copying the nodes, extruding them, copying or moving the elements, and if required, changing or assigning the properties. The advantage of this type of modeling approach, the manual modeling approach, is a complete understanding would be generated for beginners, those who are new to bridge design and also new to simulating the bridges in a software. Then for them, the understanding would be better with the help of manual modeling method. Detailed modeling for irregularities. So in case the bridge is not of irregular type, if there is some irregularity, then you can very easily do the modeling in the manual method. Coming to the disadvantages, definitely it would take a very long time if you have skewed, curved, or same type of projects each time. So you'll have to like start from scratch. So instead of that, maybe we can make use of wizards. We'll get to wizards later, but let's finish firstly with the disadvantages and a demonstration on manual modeling. And yes, there are definitely chances of missing some information which the wizard is capable of controlling. So that is about the advantages and disadvantages about the manual modeling approach. Now let's go ahead with a demonstration. So here I'm going to open Midas Civil Software Solution, where I have a model file that includes the properties. I would not be talking about the property definitions as such, just would like to show, because it's a very easy feature. You just have to go to the properties tab, click on material, and then you have to go ahead, click on add and define the materials. So I have used Eurocode database for defining the material for my girders and for my diaphragm and substructure and tendons and also dummy properties. Now we will see why we need dummy properties. Basically, when we are going for a PSC bridge modeling using all frame elements, we need to go for a grillage modeling approach, where the load transfer between the longitudinal members and the transverse members are correctly simulated. So we have C50, C50-60 for the girders, C40-50 will be for the slab, C40-50 again for the diaphragm, and then we have the substructure with C35-45. Tendons would include as 460, that is for British standard. You can also make use of the European standard over here. We have a database for the tendon properties as per Eurocode. So this is how you can even edit. And a dummy material property has been defined for the load transfers. Okay, now let's go ahead and check out the cross-section properties. So we have defined over here several cross-section properties using the PSC composite type of option available in Midas Civil itself. So there is no need of using an AutoCAD file or an importing section property calculator or third-party software. This composite cross-section was created using Midas Civil itself. So this is where you can specify the information for the slab and for the girder, and accordingly the values, the ratios are calculated. Then further we have section offsets introduced in Midas Civil. Section offsets are required to approach or to model the bridge using taking into consideration the practical conditions of transferring the forces because the girders are pretty deep. Excuse me. Yes. So after that, we have different cross sections for each part of our entire span. There is a support cross section, we have a middle cross section, and we have tapered cross section to join the middle and the supporting cross sections. So that's about support to mid, mid to support. Then we have end diaphragm and internal diaphragm, intermediate diaphragm, rectangular ones. Then pier caps have been also created. Pier cross section is with the help of solid track. No need again of using an SPC. We won't need any additional ones. I'll just change some information here for our understanding purpose. This is dummy side. It's having a very small cross-section property so that there is zero stiffness and the load is transferred completely. So that is one part. And secondly, we have dummy slab to transfer the forces in the transverse direction between the longitudinal girders. So that is it. We have 250 mm as the thickness of our deck, and we have total depth of our PSC cross section as 1.95. Okay, so after this section property definitions, we can also see there are time-dependent material properties that we have defined, and we have also linked the time-dependent material properties with the linear material properties. So this would be useful when we are creating the construction stages and checking the results after the after certain duration of time with the help of construction sequence. So let's go ahead without any further delay and start the modeling of our PSC bridge. I'll go ahead in the node element tab, create one node at 0, 0 coordinate. After this, I'll select this particular node and use my extrude elements command to convert the node into line element. I'll make use of the material property and the section property at the support. I have 2 meters of my support length. So I will divide each of my element into 1 meter length. So I'll go ahead, have 1 meter segment 2 times. This is my support cross-section length. Then I'll go ahead and use the support to mid tapered cross-section property. And this one, there is a tapering for 3 meters. So I'll make number of times as 3. Then I'll go ahead with 13 number or 13 meter of my middle cross section. So okay, here 1 and apply. This is my middle cross section. Then I'll select this one and again go ahead with 3 numbers of my tapering from mid to support. Then further the 2 meter of my support cross section. After this is done, we will go ahead and copy all of this information in the y-axis. So y direction, that's what I'm going to copy. Let's understand about the directions. X is our horizontal, y is in the transverse direction, and z is vertical. So we are going to copy our girder in the transverse direction using translate elements command, and we will provide the value of 3 meters 4 times because there are total 5 number of girders with a spacing of 3 meters each. That is done. Now we will go ahead and create our diaphragms. So we'll use create elements command and the diaphragm material and diaphragm cross section property, and we will connect the ends for end diaphragm, and we will also go ahead and create central cross section. This will be for the middle diaphragm, internal diaphragm. So here with the help of my user coordinates, I can know what is the center. So 11.5 is the center. So I've likewise generated this information. After this is completed, I'll go ahead and generate my dummy cross beams for transferring the forces between the longitudinal girders through the deck element. So I'll use dummy material and dummy slab. And this actually I will, instead of like creating by clicking on nodes one on one, I'll go ahead with the extrude nodes command, node to line element, dummy material, dummy slab. I'll go ahead with unequal distance in the y direction because it's not just 3 meters but also have some cantilever of 1.5 meter on either side. So first I'll go ahead, provide minus 1.5, and I'll click on apply. Then I'll reselect those same nodes and put them at 4 times at 3 meters and 1.5 times. And this is absolutely based on the values like 1.5, 3 meters, 3 meters, 3 meters, 3 meters, and then 1.5, like that we can provide the information. All right. So after we are done with this information, we will go ahead, create the side elements to connect all our cantilevers, because these are not separate elements. These are not separate entities as such. So we will make use of dummy side and simply click from one node to the last node. Note that the program will automatically divide the element into number of parts because of the internal nodes. So we can we don't have to worry about the information that is not allowing, or rather we don't need to worry about the load transfer because the nodal connectivity is maintained here. Okay, now let's go ahead and copy all this information for the second span. So we will select all of this data and use translate elements command and copy this distance at 23.04 meter because we have 0.4 as the gap between the two spans. And we will just intersect all, copy all attributes, and that is it. Okay, so we have completed this information. You can check that there is a gap over here of 0.4. Now we will go ahead and do one simple information that will allow us to smoothen the tapering between the middle and the supporting cross section. And to do that, we have properties, tapered group option. I'll create one group for each part. So I'll create one for this one, add. As you can see, it's very quickly completed. Similarly, this will be my second group. This will be my third group. Then I have my fourth group. Oh, I think I did not. This is already done. Okay. So this is my fourth group. Yeah. So I have done the smoothing of my tapered cross sections. The program automatically calculates the intermediate cross section property. Let's now go ahead and model the substructure. So to model the substructure, firstly, let us copy the nodes, the supporting nodes below our below our girders. So we will definitely use node element and copy the nodes at a distance of minus 1.95 because that's the total height of our girder, PSC girder, including the deck. But we are also going to include the elastic links with the help of bearings. So for that, let us use the unequal distance to firstly copy at minus 1.95 and then copy it minus 0.1. So in this way, we have created the nodes for the top of the elastic link and the bottom of elastic link. After this is done, let's move ahead and model our pier. So firstly, we will start with the modeling of our pier cap. Here, let us select this distance, this particular node, and translate it at a distance of 0.02. These would be the central nodes. These would be actually the nodes of our pier cap. So let us model the pier cap. I've selected these nodes and I've activated them. And now with the help of create elements command, we will simply go ahead and model the substructure pier cap. That is it. Now let us select this particular node, central one, and extrude it downwards into a pier. The height of the pier is 10 meters, so we'll provide minus 10 and apply. So in this way, we have completed the modeling. We don't need these nodes here. Let's delete them. And this is up to here itself. Okay, so here. Yes, so here we have completed the modeling, manual modeling of the PSC girder bridge. Now let us move ahead to the next part, that is using the wizards. With the help of wizards, we can create this entire PSC bridge in one single click. So let us go ahead now and understand the different types of wizards in Midas Civil. Midas Civil includes wizards for all types of bridges, even the basic bridges. We have RC slab bridge wizard, box culvert wizard, the free cantilever or balance cantilever and full staging method wizards for box girders. Then moving scaffolding method, incremental launching method. So based on the construction sequence as well, Midas Civil has created the wizards. Suspension bridges, cable stayed bridges are also can be also generated with the help of wizards. And then when it comes to transverse analysis, we have the grillage modeling and the for long span for the long rails, we have rail track analysis too. And finally, we are talking today about the steel composite and the PSC composite bridge, or rather the PSC composite bridge wizard. So let us now, before we go for the summary, let us now go ahead and see how to quickly do the modeling of our PSC bridge, two-span PSC bridge using a wizard. So I'll firstly save this and open my model, which contains the material and the section properties, and also the time-dependent material properties are there. I have also included the tendon properties because we can actually create the tendon profile and construction sequence and the loadings along with the model using the wizard. Wizards are available in the structure tab. We can use PSC wizard from here. The good part about Midas Civil is all the wizards include some reference images using which we can provide the inputs and generate the entire bridge. Another good part is that we can save our bridge wizard and open it for using it for your future projects with slight modifications. So what do these wizards contain? These wizards contain information about the alignment, the layout, that is. So you have two spans at 23.02, that is center to center. Then we have a deck width of 15 meters. The spacing between two spans is 40 mm, and there is a distance of 500 centimeter, 500 mm, 0.5 meter between the edge of the span and the center of the support. So this one was not actually modeled in the manual, but you can definitely do that very easily in the manual modeling approach too. Okay, then further we have option to make the girder continuous or not with just one checkbox. Curve type of or skewed type of bridge bridges can be easily modeled. You can model the superstructure with or without the substructure. So if you have included the substructure, then you can model the pier cap data, the bearings with the help of elastic link data, basically the boundary conditions as well as the substructure data, like the pier and the column, the height, the lengths, and how many number of piers for one single support can be specified. So that's about the layout. Then the section. Now we tell the program which cross sections are to be used where. So here is the deck thickness information, how many number of girders are there, what is the spacing of the girders from the center, then what material property is applied to the deck, girders, diaphragms, then further which diaphragm is at what location, how many number of diaphragms are included, what should be the spacing for the division of our entire bridge span. Then further there are span information, like how many number of parts is the entire span divided into, and what are the cross-section properties for each part of, like the 2-meter support cross-section, then 3-meter tapered, then 13 meters middle section property likewise. So you have information for both spans. Then you can finish after this, like layout and section is all you need for the cross section for the modeling. But apart from the modeling, you can also input the information about the tendon profile and the tendon properties that include the short-term and long-term loss coefficients. Then the loads, like the dead loads and the live loads, can be included with the traffic lanes. We will discuss more about this information, the load information, in the next session. We can also include the construction stages. So this is what the program will by default generate. In case it is different, then we can definitely modify the data during or after the wizard. You can also apply reinforcements to your cross sections. So this is also one good approach in using the wizard itself. And the reinforcements can be used for the stiffness of your cross section in the analysis. So after this is done, let's just click on OK, and our bridge is generated. So it was just one click and our PSC Bridge wizard is completed. Good part is that you can further modify your bridge wizard after you have used it. So it's like just one useful tool to create the model. It is not like unlike other programs where you can use only the wizard for generating the bridge. That's not the case in Midas Civil. After you use the wizard, you can still edit your entire model because this is just node and element. So you have complete information over here in the workstream menu. You have the loads as well as the tendon profiles. So everything is generated with the help of the wizard itself. So that is it. Now let's wind up today's session and summarize. So today in session 1, the modeling PSC Bridge Wizard using Midas Civil, we saw that at the beginning I explained about how all types of bridges can be modeled and designed. Then we also talked about the manual modeling approach where desired details can be simulated. And also we saw a variety of modeling approaches, with different ways of simulating different types of bridges. Then even the PSC bridge itself could be simulated in using different elements. Then you can also save a lot of time with the help of wizards. PSC Composite Bridge Wizard is available along with other wizards. You can have complete control on the connectivity and load transfers because we have a node element modeling approach in Midas Civil, unlike other programs where you have member-based modeling. So it's not a black box. You have complete control. Even after the wizard, you have complete control on how the nodes and elements are placed. Lastly, it's an all-in-one modeling tool where you can model not just the superstructure, but also the substructure and the foundations. So that is about Midas Civil Software Solution, session 1, where we saw the different modeling approaches of a PSC composite bridge. So thank you very much, everyone, for attending today's short webinar series. If you have any questions, like you have already sent me some of the questions, so I'll definitely get back to you over the email. And we will also have a small question answer session tomorrow before we begin to answer these that were questioned today. If you have any questions related to the licenses, then please contact Pankaj at midasit.com. And if you are a user, definitely you are eligible to use our globalsupport.midasuser.com portal, which can help you to get solutions within 24 to 48 working hours. So that is it from my side. Thank you very much for attending this session. I hope to see you all again tomorrow. Bye-bye.